compressed air systems are governed by several regulations and standards, most notably OSHA regulations under General Industry 29 CFR 1910.194, Shipyard Employment 29 CFR 1915.12, and Construction 29 CFR 1926.302. The ANSI/USME B40.1-2018 standard also provides guidance on compressed air systems. When installing a compressed air system, there are several key components and installation requirements to consider. Firstly, the air compressor should be located in a well-ventilated area, free from dust and moisture. It must be equipped with appropriate safety devices such as a pressure relief valve and overload protector, and properly maintained and lubricated according to the manufacturer's instructions. Secondly, the air receiver should be installed in a convenient location, accessible for inspection and maintenance. Its size must be adequate to store sufficient air for system operation. It should be equipped with a pressure gauge, safety relief valve, and drain plug. The air receiver should also be installed on a stable foundation with appropriate support. Thirdly, when it comes to piping, Schedule 40 or thicker black steel pipe, or an approved equivalent, should be used. Piping must be properly supported to prevent excessive vibration and routed to avoid excessive heat sources or corrosive environments. Expansion joints or flexible connections should be installed to accommodate thermal expansion. Fourthly, concerning hoses, only approved reinforced rubber hoses should be used for compressed air applications. The maximum length of hose permitted between the air receiver and the first point of use is as follows. Firstly, 50 feet for 1/2-inch hose. Secondly, 25 feet for 3/8-inch hose. And thirdly, 10 feet for 1/4-inch hose. Hose connections should be secured with clamps or other approved methods. Fifthly, shut-off valves should be located at the compressor outlet, air receiver inlet and outlet, and downstream of the shut-off valve at each point of use. These valves should be easily accessible for emergency shutdown and equipped with pressure gauges to monitor system pressure. There are several critical safety requirements for compressed air systems. Pressure relief valves should be installed on the air receiver and compressor to prevent overpressurization. These valves should be set to open at a pressure slightly below the maximum allowable working pressure of the system. A drain valve should be located at the bottom of the air receiver to drain moisture and condense it. This valve should be operated regularly to prevent buildup of water and corrosion. Safety tags should be attached to the shut-off valves and other critical system components to indicate their function. These tags should display warning labels with appropriate safety instructions. Personal protective equipment, or PPE, such as safety glasses and earplugs, should be worn when working on or near compressed air systems. It is crucial to provide training to all personnel who operate, maintain, or use compressed air systems. Regular maintenance is also essential for ensuring the safe and efficient operation of a compressed air system. This includes checking for leaks, inspecting hoses and connections, and draining moisture from the air receiver. Using the correct type of piping is critical for safety and efficiency in compressed air systems. Schedule 40 steel pipe is commonly recommended due to its durability and ability to withstand high pressure. However, alternative materials such as copper, stainless steel, or specialized aluminum piping systems can also be used, provided they meet the pressure and temperature requirements of the system and are approved for compressed air applications. When selecting piping materials, it's essential to consider factors such as the operating pressure of the system, the ambient temperature, and the potential for corrosion. It is also important to ensure that all piping components, including fittings, valves, and connectors, are compatible with the chosen piping material and are rated for the intended pressure and temperature. Proper support of compressed air piping is essential to prevent sagging, vibration, and potential damage to the system. Piping should be supported at regular intervals using appropriate hangers, clamps, or brackets. The spacing between supports will depend on the size and type of piping used, as well as the operating conditions of the system. As a general guideline, horizontal runs of steel pipe should be supported every 8 to 10 feet. Vertical runs should be supported at least every floor level or every 10 to 12 feet. It is also important to provide additional support at points where the piping changes direction or where heavy components such as valves or filters are installed. Support should be securely fastened to the building structure or equipment and should be designed to withstand the weight of the piping and any additional loads imposed by the system. Proper drainage of moisture from compressed air systems is essential to prevent corrosion, damage to equipment, and contamination of the air supply. Moisture can condense in the air receiver, piping, and other components of the system due to temperature changes and the compression process. To remove this moisture, drain valves should be installed at the lowest points in the system, such as at the bottom of the air receiver and at low points in the piping network. These valves should be opened regularly to drain any accumulated water and condense it. Automatic drain valves are also available, which can be programmed to drain the system at predetermined intervals. In addition to drain valves, air dryers can be used to remove moisture from the compressed air stream. Air dryers work by cooling the air to condense moisture or by using a desiccant material to absorb water vapor. The type of air dryer used will depend on the required air quality and the specific application. Regular maintenance of drain valves and air dryers is essential to ensure their proper function and prevent moisture buildup in the system. When selecting compressed air hoses, it is important to choose hoses that are specifically designed for compressed air applications and that meet the appropriate safety standards. These hoses are typically made from reinforced rubber or other durable materials that can withstand high pressure and resist abrasion and degradation. The maximum allowable working pressure of the hose should be clearly marked on the hose itself. It is important to choose a hose that is rated for at least the maximum pressure of the compressed air system. The length and diameter of the hose should also be selected based on the specific application. Longer hoses will result in greater pressure drop and reduced airflow, while smaller diameter hoses may restrict airflow and cause excessive pressure drop. Hose connections should be secured with clamps or other approved methods to prevent leaks and accidental disconnections. It is important to inspect hoses regularly for signs of wear, damage, or deterioration. Damaged hoses should be replaced immediately to prevent accidents and ensure safe operation. The placement of shutoff valves in a compressed air system is critical for safety and maintenance purposes. Shutoff valves should be installed at strategic locations throughout the system to allow for isolation of specific sections for repair or maintenance without shutting down the entire system. As mentioned previously, shutoff valves should be located at the compressor outlet, air receiver inlet and outlet, and downstream of the shutoff valve at each point of use. Additional shutoff valves may be needed depending on the size and complexity of the system. All shutoff valves should be easily accessible and clearly labeled to indicate their function. In addition to manual shutoff valves, automatic shutoff valves can be used to provide additional safety and control. These valves can be programmed to automatically shut off the air supply in the event of a system malfunction or emergency. Pressure relief valves are essential safety devices that protect compressed air systems from overpressurization. These valves are designed to automatically open and relieve pressure when the system pressure exceeds a predetermined set point. Pressure relief valves should be installed in the air receiver and compressor, as well as at other locations in the system where overpressurization is possible. The set point of the pressure relief valve should be slightly below the maximum allowable working pressure of the system. It is important to inspect pressure relief valves regularly to ensure that they are functioning properly. These valves should be tested periodically to verify that they open at the correct pressure and that they are not blocked or obstructed. Safety tags and labels are important tools for communicating safety information and preventing accidents in compressed air systems. Safety tags should be attached to shutoff valves and other critical system components to indicate their function and provide instructions for safe operation. Warning labels should be displayed prominently near compressed air equipment and in areas where compressed air is used. These labels should warn of the potential hazards associated with compressed air and provide instructions for safe use. All safety tags and labels should be durable, weather-resistant, and easy to read. They should be regularly inspected and replaced as needed to ensure that they remain legible and effective. Proper training is essential for all personnel who operate, maintain, or use compressed air systems. Training should cover the potential hazards associated with compressed air, as well as the proper procedures for safe operation, maintenance, and repair. Training should also include instruction on the use of personal protective equipment such as safety glasses and earplugs. All personnel should be trained on the location and function of shut-off valves, pressure relief valves, and other safety devices. Refresher training should be provided periodically to ensure that personnel remain knowledgeable and proficient in safe work practices. Personal protective equipment (PPE) plays a vital role in protecting workers from the hazards associated with compressed air systems. Safety glasses or goggles should be worn whenever working on or near compressed air equipment to protect the eyes from flying debris. Earplugs or earmuffs should be worn in areas where noise levels exceed 85 decibels to protect hearing from damage. Gloves should be worn to protect the hands from cuts, abrasions, and other injuries. Safety shoes or boots should be worn to protect the feet from falling objects and other hazards. All PPE should be properly fitted and maintained in good condition. Regular inspections should be conducted to ensure that PPE is in good working order and that it is being used correctly. In addition to the specific requirements outlined above, there are several general safety precautions that should be followed when working with compressed air systems. Always disconnect the air supply before performing any maintenance or repairs. Never point a compressed air nozzle at yourself or others. Use compressed air only for its intended purpose. Avoid using compressed air to clean clothing or body parts, as this can force air into the bloodstream and cause serious injury. Be aware of the potential for noise hazards and take appropriate measures to protect hearing. Report any leaks, malfunctions, or other safety hazards immediately. By following these safety precautions and adhering to the applicable regulations and standards, it is possible to operate compressed air systems safely and efficiently. Remember to consult the manufacturer's instructions and seek professional guidance when needed. In summary, safe and efficient operation of compressed air systems hinges on several critical factors. Firstly, adherence to OSHA regulations and ANSI/SMS standards is paramount. Secondly, proper component selection, including air compressors, receivers, piping, and hoses, is crucial. Thirdly, strategic placement of shut-off valves and pressure relief valves ensures safety. Fourthly, regular maintenance and drainage of moisture prevent corrosion and damage. Fifthly, comprehensive training and use of PPE protect personnel. Lastly, consistent safety practices minimize risks and promote a safe working environment. By prioritizing these elements, you can ensure the reliable and safe operation of your compressed air system.